Alright, so this is the review on substitution and elimination for the quiz that will be tomorrow. So we're looking at the first review page, and this happens to be using substitution as the first three problems. So whenever we deal with substitution, it normally means it's going to have one of the variables by itself, like the equation 2 for this first one. It's got y by itself. So whenever we have the variable by itself, we want to know what it's equal to. In this case, y is equal to x plus 7. So we want to plug x plus 7 for wherever we see a y in the other equation. So in this case, it's going to be x plus 7, and that's equal to 17. It will help to always put parentheses around, just in case if you end up having to be multiplying this by a number or like a negative one or something like that, so that way then you're keeping an eye on what you're actually distributing. So in this case, we just want to combine like terms because we're not dealing with any multiplication. So it'll be 2x plus 7 is equal to 17. Alright, so remember, we want to get x by itself because we're solving for x. So then I would minus 7 to both sides, and I get 2x is equal to 10. Then we want to divide by 2, and I get x is equal to 5. So now we know what x is equal to. We want to now find out what y is equal to, because we need to find the solution to the system. So all you have to do is plug in what your value is for x, and then plug it into back to one of the two original equations. I would choose the second one here because it's already solved for y. You just have to plug in x. So we know y is equal to 5 plus 7, which means y is equal to 12. So then you need to write your solution, which would be what x is 5, and then what y is 12. So then the solution to this system is 5, 12. Now let's look at number 2. Number 2, we have our first equation here has y by itself. So that means we're going to plug in x minus 19 and forever we see a y in the second equation. So the 2x minus x minus 19 in parentheses equals 27. So you see we have this negative out in front of the parentheses here, which means we're going to distribute that negative to both the x and the negative 19. So then whenever you do that, it should be 2x minus x plus 19 is equal to 27. Next, you want to combine any like terms. In this case, it's x plus 19 equals 27. And then we want to get x by itself. So subtract 19 to both sides, and I get x is equal to 8. So now we know what x is equal to. Now we want to plug that back into one of the first two equations to solve for y. I would choose the first one because it's already solved for y. So y is equal to 8 minus 19. So then y is equal to negative 11. So that means then our solution to this system is 8, negative 11. You always want to write down your solution points. Alright, let's look at this last substitution problem. The first equation has x by itself, so we're going to use that to substitute into the second equation. So it looks like x is equal to y plus 2. So wherever we see an x, we're going to plug in y plus 2. So we have y plus 2 plus y equals 8. Once again, combine like terms if you don't have to distribute. So 2y plus 2 equals 8. Then you want to get y by itself, so subtract 2 to both sides. Get 2y is equal to 6, and divide both sides by 2, and you get y is equal to 3. Alright, since we now know what y equals, we want to find what x. I would plug it into the first equation right here, because it's already solved for x. So x equals 3 plus 2, which means x is equal to 5. So now knowing what our variable is equal to, we can just plug in the solution. So we shoot 5, comma 3. So that's substitution. You only really ever want to use substitution whenever you do have one of the variables by itself. If not, then you'll probably end up using elimination, which is what we're going to go over next. So numbers 4 through 7 on this review go with elimination. So let's look at number 4. We want to see if we can find any variables canceling out. If we look right here, we have a positive 3y and a negative 3y, and if you add those two together, you're going to end up eliminating your y's. So that's what we want. So we don't have to worry about multiplying anything with this one. So all we want to do is just add up these two equations together. Remember, you're adding them just going straight down. So in this case, we're going to have 6x, the y's end up canceling out, is equal to 30. So divide both sides by 6, you get x is equal to 5. Alright, so now we know what one of the variables are. We want to solve for that one. So put this back in to one of the two original equations. We'll choose the first one. It really doesn't matter which one. You should get the exact same answer for both. Get 2 times 5 plus 3y equals 34. 2 times 5 is 10. It's 10 plus 3y equals 34. Then you want to minus 10 to both sides. You get 3y is equal to 24. Then divide by 3, and you get y is equal to 8. So now we have what x and y are equal to. So now all we want to do is put it in the point form. So it's 5, 8. So that's your answer. Okay, let's look at number 5. First we want to check and see if we can have anything that eliminates right away. Once again, we're able to get rid of our y, so we have a positive 7 and a negative 7. So once again, all we have to do is just add straight down. So we have a 4 plus a negative 12, which gives us a negative 8x. The y's end up going out, and then we have a negative 6. Now this one you will see that we won't have a nice even number, but we will get a decent number. It will be a fraction though. So then divide both sides by 8, negative 8, and you're going to get x is equal to 6/8, which is 3/4, or if you put in your calculator, it's 0.75. So now we know what x is equal to. Solve for y. Plug it back into the first equation. So we have 4. I'm going to use the fractions to see how it would work here. So 4 times 3/4 plus 7y equals negative 25. 4 times 3/4 will give us a 3 plus 7y equals negative 25. Then you want to subtract 3 to both sides, and you get 7y is equal to negative 28. So then divide by 7, and then you get y is equal to negative 4. So that means then the solution is 3/4 or 0.75 comma negative 4. So even though this answer may look weird, you can have fractions. It's just sometimes you get fractions, but then you can get whole numbers for the other answer. And if you're not sure if you got the right answer, always plug your solution back into your equation, so that way then you can see if it works out. That's the best way to check your answer. Alright, let's go to number 6. Alright, number 6, it doesn't seem like we can eliminate any of the variables right away by just straight addition, so we're going to have to manipulate at least one of the equations. Now normally, how I've been telling you guys is, look and see if you have a positive and negative variable. And if you do, you might want to choose that one first to get rid of, because that might be easier, so you don't have to worry about multiplying by any negatives. So in this case, number 6, we have a positive 2x and a negative x. So I would think we would maybe get rid of these x's. And we need to see what's in common with 2 and 1, because and 1, since we know that that number in front of negative x is a 1. In this case, it's 2. So that means we have to get both of these x's to be 2. Well, luckily in this first one, we don't have to worry about multiplying anything. It's already 2. So that means we're going to multiply the second one by 2 in order to get our x's to cancel out. So whenever you multiply this by 2, you want to multiply everything by 2. So it means we're going to take 2 times negative x, to be negative 2x, plus 2 times 3y, 6y, equals negative 12 times 2, which is negative 24. So once you have it, pretty much ignore the middle equation for right now, and just look at these last two. This first one and the last one here. So we're adding them together. The two x's end up canceling out, and you get y plus 6y should be 7y, and 3 plus a negative 24 is negative 21. So then you want to divide both sides by 7, you get y is equal to 3, negative 3. So now we found y. Go ahead and plug back into either one of the first two original. We'll choose the first one. We get 2x plus a negative 3 equals 3. Then you want to add 3 to both sides and get 2x is equal to 6 divided by 2, get x is equal to 3. So now we have the solution. It's going to be 3, negative 3. Alright, let's look at this last one here. Once again, we don't really have, whenever we do straight out, we aren't able to eliminate any of the variables. So let's look and see. Alright, looks like y has a negative and a positive, where x says 2 positives. So I would maybe choose y. So that way we can not have to worry about multiplying any negatives. We see we have a negative 1 and a positive 3. So what is a common factor of 1 and 3? It's going to be 3. So it means we have to get this to be 3y. So we need to multiply this top one by 3, and we don't have to worry about multiplying this one at all. So let's multiply the top one by 3. So 3 times x is 3x, minus 3y is equal to negative 9. Let's look at these last two equations right here and just add them up. You get 8x, y's end up canceling, and you get equal to negative 8. So you go ahead and then divide both sides by 8, you get x is equal to negative 1. So now we know what x is equal to, we want to find out what y. So I would go ahead and plug this into the first equation. So we have negative 1 minus a y equals a negative 3. Go ahead and add 1 to both sides, and you get negative y is equal to negative 2. But that's not your final answer, because you need to have it to where y is positive. So we need to divide both sides by negative 1, and we get y is equal to 2. So then now we know the solution then is negative 1, 2. Alright, so those are the answers to the first review sheet. I'll be going over the second worksheet in the next video. But also, whenever you're doing with elimination, you want to make sure that you are eliminating a variable. You can do, in any of these ones, you could have eliminated an other variable, it's just you may have had a little more work to it. But there is no, as long as you end up getting the same answer, if you chose to get rid of the x's instead of the y's, then you're fine. Just as long as you just understand the process, that's all we're looking for.